So we're doing a project, and I thought I'd give a brief introduction about how the HCS12 microcontroller works. Um, so we've been programming the boards using the Code Warrior software, assembly language, of course, um, and we've been mainly working with the push buttons, the pin switches, the LEDs, and the 7-segment displays. So the function of the 7-segment display is to really display a message, display time, display really anything you want it to. It could be anything. So the LEDs, um, you could create a pattern. You could create a delay, so like a flashing red, flashing green with a delay in between, sequential LED. You could program it to do whatever you please. So the function of the pin switches and the push buttons really is to control what's going on over here. So for example, let's say we put up the first two pin switches and we program the board so that once you click push button 1, these two LEDs will light up. So that's just the example. You could program it to do whatever you want it to. So so now let me show you guys how to connect the board to the computer. So we got this cable. This end goes into the board, and then the other end goes into your computer. And then it turns on. So here's a little example related to what I was talking about earlier. Um, we programmed the board so that when pin switches 5, 6, 7, 8 are up, and only when they're up the LEDs will light up. Based on what LED you want to light up, this is also another way to program. Based on which LED you want to light up, you got to push that pin switch up as well. So let's put this down, and it's programmed for push button 1, and let's click it. So nothing happens. So let's put it up, let's click it, that lights up. So let's click it again, it goes off. So let's go to pin switch 3, put that up, see which one lights up. Let's put multiple up. So this is also an example of polling. Now let me put these down, see what happens. Put these up. See? Now it doesn't light up. So yeah, that's just a little demo I threw in there. So for the project, we decided to go with a sequential LED. We decided to do this because it's used in real life applications such as cars, crossing signals, and many more. So this is pretty simple. We created a table which allows the LEDs to light from left to right using the hex values for port B, and using a loop. It's pretty simple, and the subroutine for the delay. It was pretty straightforward. So without further ado, next I will explain the actual code
and how it works. This is the code for the sequential LED that we came up with. Give you guys a brief look, and then I'll get into detail with it, and I'll explain what everything is. So these are our definitions. We got count, we got the table, which is the pattern that we want our LEDs to light in. We got the LED enable, which is going to enable the LED. Load stack pointer 4000. This is making the port B the output. This makes pin J1 output. Enables the LEDs for us. Disables the 7 segment. And then we jump, the code continues over here. Move byte number 8 into count. That's the total number of values we have. And then we load the LED table into the X register. And then this is where our loop starts. Move byte, it keeps looping until it goes through all the numbers. Increments X. Then we got our delay, which is over here, 750 milliseconds. And then it decrements count. Branch is not equal to loop. Goes to loop. And then branch forever. So that's about it.